So when we last left off, we built our very first Pygame program sketch to put into the Critter and Guitari ETC. Now there's a few problems while I was developing that sketch itself. So the biggest one for me is the fact that you don't get to see any of the errors in the code that you're writing, right? So if I broke something, I wouldn't be able to tell except for I'd have to notice visually that the changes I made weren't really happening. So in between the last video and this video, I've written a script to implement just a basic sanity test for the Critter and Guitari ETC. So the way this works is you run it on your local Python environment. You have to, of course, have Pygame installed. And so what you do is you do Python 3 etc-test, and then you send in your program that you want to try testing. So here I'm going to do the sine wave program that I generated before. And so it defaults to some variables, so you can tell if you look at my screen versus what's running on the Critter and Guitari ETC right now, obviously those knobs have changed a bit, and so they have different values. But if and you can also see what the colors really look like in some cases here. If I press spacebar, I'm going to get the other visual that I would trigger with that trigger, and if I press Z, I go back to the original program. So this takes in basically any sketch you have in the Critter and Guitari ETC and turns it into a program you can run locally. This is great because if you write a program and you want to know where it's not working, you'll get the Python errors here. And so yeah, there's this etc object I created. You pass in just the name of the Python program, and you can say sinewave.py. So sinewave.py is exactly what I typed into the Critter and Guitari ETC. So this is just that program copied and pasted into here. And so this etc test takes in the file name of what we call a module, and then it imports that module, sets up the screen to be the same resolution as the Critter and Guitari ETC, creates a dummy etc object using random values, so it even populates the audio in with something, so that you have something to work with. And then basically it starts a Pygame loop. So you press spacebar in order to trigger that audio trigger event, and then you press Z in order to untrigger that audio event. So between the two of those, you kind of have a little bit of feedback there. And then finally you have the Q button in order to quit the entire program. So this is basically the start of a more easily debuggable space to build your own programs. I'm going to put this on GitHub, and so the next thing I'm going to do is jump into adapting an existing program I wrote called 10print, which really isn't my program at all really either. That's out of that book 10print that I adapted to Pygame. But anyways, I want to use the audio input from the Critter and Guitari ETC and show you what that looks like in a a fully modular, changing all the knobs type program. So let's first run this 10print original program in case you haven't seen it. There is a video that I already made of it. So let's do 10print og.py, and you're going to see, if I hit space, you're going to see what the program is. So it just basically rolls a random dice, and if it basically rolls heads or tails, and if it's heads it goes one way, and if it's tails it goes the other way, and it just does that across the entire screen. So we're going to take this program and we're going to adapt it for the Critter and Guitari ETC. So the way that'll work is we're going to first develop locally, and then we're going to copy and paste it into our live coding environment that we have in our web browser here. And so I've actually already finished this. So if we take a look at what I've built first, let's see if this loads. If I click testing, and I click save, There we go. So now you can see we've got a little bit of the jitter. If I press the piano, you'll see that it shakes along with the audio. And then if I get my audio to also trigger an event, or do that trigger, it'll also switch for every event. So let me adjust the knobs so you can see what we end up with. So this knob changes how many of the squares we print. And so if I go all the way down, or no, this is actually the thickness of those squares. So if I go all the way down, you're going to see that the squares get very thin, and then all the way up, super thick. And so this one is the knob for how many of those lines we make. Oh no, this is for how sensitive the audio is. This one, it's gotta be, yeah, here we go. This is the one for how many of those lines we make. And then this one is for how sensitive it is to the audio. So you can tell we get kind of a cool effect. And then finally the fourth knob is for color, as usual. And yeah, the other one's background and threshold for the knob. So if we wanted to, we can have it to where mostly don't move that much, except for once we get those on set. So if I turn this all the way down, we should just change with those triggers. So cool. Let's jump into that code. Let's pause the audio. And let's jump into the code to see what that looks like. So there's a few things here. I've taken a set of functions, and these are rotate and rotate line points. So this is going to take in a start and an end position and rotate it around the center. So each one of these lines that we have in our 10 print is going to rotate around the center of the line. So unfortunately, the code to do that isn't really too straightforward, and so I've imported these functions that do that for us. So we generate so we have the squares variable, right? This sets how wide in pixels our squares are. Next, we have a lines variable that's set to actually be an empty list. So then we populate that empty list with a square all the way across the entire screen from 0 to 1280, which is the width, and then we do the same thing for the height. For every row from 0 to 720, you create those squares. And of course, by changing those numbers, you can or changing the square, you can get a bigger or smaller line, and that's what we've got attached to one of the knobs. So here I've done my very first setup function, and we create the global of lines because we want to be able to change it inside of each of these functions, and then we set the lines to be the results of generate lines. And so one thing I want to note here is that I've added this lines equals 0, so I reset lines into an empty list every time. Otherwise, this function would just keep adding new lines and it would just fill the screen. And that's a cool effect, but you don't really need to do that here. You can use the button on the ETC right here, which is, I think it's that one, which is the button that allows you to not clear the screen after every draw. And you get a very similar effect. Finally, we get into the draw, right? And this is where everything happens. So the very first function, the very first variable we do after declaring that lines and the squares are going to be our globals is we set the color with a color picker. And again, this is the fourth knob on the Critter and Guitari ETC. Then we set the thickness. So the thickness is going to be that first knob, right? And so we always need to have at least one, right? So it's got to always be at least 1 pixel wide. And then we can add it to whatever the value of the knob 1 is. So remember, from 0 to 1 as a decimal, and then times 20. We could go bigger with this. Let's say 40, and let's save it. And so you can tell we get a much thicker line. And so you kind of get this bigger value or bigger set of values for how big you can make the lines. Let's actually go even bigger than that. Let's go all the way up to, let's do 80, just to see what it looks like. And then if I go down, hit save, you can see that now this is really different from what we had before. Let's try playing our audio again and see how this looks. Okay, that's interesting. Very different, very glitchy compared to what we had before. And we can still go down and see what's going on with our onset detections. And I have the audio level off, so let's turn this up, and let's turn this up. And you can see we're almost in an entirely different universe just by adding that extra thickness going beyond what would seem reasonable. So here we are, and you can see we've got our audio effect and our onset. And then we can go all the way down here, and we get basically what feels like an entirely different program if we adjust our knobs, right? So we're here, here. This is almost a little bit too much. It just barely holds on the screen. And then right at the threshold there, you can kind of see the negative space for our line. And then here it gets really thick and really kind of, just kind of fun to play around with. All right, so let's keep going with the code. Let's not get distracted by that. So going back to the code, right? We have the thickness, and so that knob we can change. And then the same thing with our squares. So I've set my squares to be at least 50 pixels wide, and I did that because the Pygame, the Critter and Guitari ETC starts to bog down a little bit if I get that much lower. So let's change this. Let's say 40 is the minimum, and then we can go all the way up to 100. Or no, let's do 300. Let's try saving that. And let's see how that changes things. So if we adjust this knob. Oh, and then we have to have an onset event happen in order to trigger that new size. So there we go. Now you can see the bigger size of these guys. And it kind of mostly takes up the full screen. Let me turn down the effect. There we go. And then this should be about as wide as it gets. So if I go back down, you can tell as I go further down, I'm going to take this down too. As we go down, you can start to see everything change. And one really great thing about the ETC is that it gives you the ability to kind of play around with your code right away, right? These knobs and dials give us a way to understand what's happening within the code without having to stop our program and then run it all over again. So one thing that I'm noticing is when I get up to the bigger level, I definitely want to have a thicker line, at least for me. And then I don't know if I like it moving around too much, so the second knob should go down. Alright. So we've got thickness, we've got how many squares to draw, and let's scroll back up so where you can read it. So we've got thickness, how many squares to draw, and that's the third knob, right? And we're doing the same thing here. Let's fix up our code so that it makes more sense. So we're doing that etc.knob3 times 300. And we can actually do something, I think this makes sense. Let's do 600. Because I think that would be half the screen, and I think that's as much as makes sense. Actually, you know what? Why make sense, right? Why make sense? Let's go the whole width of the screen. And let's see how that looks. And again, we need to do that onset triggering, so let's do that. Let's keep this audio rolling. And then there we go. There's our one line that kind of bounces around for our scope. And that gives us our audio feedback, right? So if we bring it all the way down, you just see one line going back and forth. And we can bring this guy down. From one line, two lines. And then this makes it really much more sensitive. Especially as it gets lower down. That's one of the trade-offs to think about when you get these really high values. So I'm already almost at the very minimum here. But if I bring it up just a little bit, I already get to the huge, sort of almost full screen stuff, right? It's because when I go to halfway, I'm only getting 2. And then when I go a quarter of the way, I'm getting 3. And then like the very minute adjustments here are where I start to get into everything. See that I lose that kind of longer set of values, but you know, it's kind of a trade-off to make on your own. All right, so we've got our squares. I'm gonna keep it at 600. I think that I like that better. And then we jump into the audio trigger stuff, right? So if the audio is triggered and we have that threshold knob, we're gonna generate a new set of positions for those lines, right? We just call that generate lines, and then that function is going to again just generate that entire array for us. So it's going to be a whole new random sort of that. And then we just say for each one of those lines, let's take the first and second element of that array, and then let's take the elements after the first and second element, and let's put them into a line 1 and a line 2. And so it's going to be an X and a Y position and an X and a Y position. So a start X and Y and an end X and Y. And then we're just going to draw a line using the color that we chose on our color picker, which again is that fourth knob, and then, you know, from line position 1 to line position 2, with the thickness that we set with that knob 1. All right, so if we're not doing an onset, then we're going to be doing this rotate line point function that we talked about earlier. So remember, what we're doing with that rotate line point is we're rotating around the center of our X and Y two positions, right? We have a start point, an end point, and then we want to take the middle point of that and rotate around the middle point of that by some value. And so what we do is we take each one of the lines that we have in our line list, right? So depending on the size of the square, we're going to have a different number of elements in our list. So we do what's called modulus. So this right here is the modulus operator. The modulus operator is going to keep our number always between 0 and 99. So we do that in order to make sure that we don't try to access an element that isn't in this audio in. So audio in is a list with 100 elements, and each one of those 100 elements is an integer with a value between around negative 32,000 all the way up to positive 32,000. And so we need to, in order to have that value be a little bit less huge, we multiply it by 0.01. And so that kind of dampens it and makes that value much less. And then we multiply that by our knob 2 value. And so generally speaking, that means that we can have this value rotating our all of our squares by that dampened value and then by that amount that we control with the knob. And so if I set it to the knob only, you're going to see that it just fluctuates so much that it's not even fun to look at. So we send this audio in, so the amount the audio is fluctuating in as the amount to rotate that center point on that line by. So our function, rotate line points, if we look at it, is going to return a new start, so a new X and Y for our beginning position, and then a new end, so a new X and Y position for our end. So we take those 2 points and then we just draw a line. And so every time we loop around through this draw program, we get the same thing. So with that, that's how we have our entire program. This program will also run in our Pygame environment. So let's close out of this and see what it looks like inside of that test environment that I wrote. So if we do Python 3 test dot, no, what is it called? etc-test, etc-test.py, and then we do 10-print.py, you're going to see this is what that sample looks like. And so if I do a trigger with the space bar, you're going to see that it's going to do that random loop over and over again. So it's not really the best to check out in this case. But it's a good place to just do a sanity check and see whether or not the code you've written for your program actually works. So it's kind of a lot here, but we did go through basically all of the features of the Critter and Guitari ETC. We got a program that runs using the trigger and a program that runs using the audio input. And we also generated a really quick and dirty test environment in order to make sure your programs are written properly before you try running them on the Critter and Guitari ETC. So that's a lot. It'll all be available on GitHub, and I'll do a write-up on my blog where you'll be able to see it all. All right, thank you.